Selection for section 6.2, college algebra. So we're going to be talking about one-to-one functions and also inverse functions. So basically a function is one-to-one. If for any two different outputs, x1 and x2, x1 and x2 do not equal to each other, then it corresponds to two different outputs. In other words, f of x of 1 does not equal f of x of 2. The horizontal line test is basically if I have a function, right, so I'm going to do something like this, and I do a horizontal test, just like we did the vertical. If it touches the graph at two distinct points at the same time, then it would not be a one-to-one function. The other thing we're going to talk about here is inverse functions. So inverse functions, basically what we do is we swap the domain and the range. So in other words, the domain of f would be the range of the inverse function, and then the range of f would be the domain of the inverse function, basically just swapping them. Another thing is if they're inverse functions, so the inverse of f of x is equal to x, and f of the inverse of x is equal to x. Number 28, you would have to look in the textbook, but it says find the inverse. All we have to do is interchange the element of the domain with the elements in the range. So in other words, the domain in the original would be the dollars, the range would be the title. If we find the inverse, we will switch those, and the domain would be the titles, and the range would be the total amount. So the next thing we're going to do is we're going to go ahead and do number 36. So number 36, what we're trying to find out is, are these two functions inverses of each other? So in other words, is this true, right? And we did this in the previous section. So does f of g of x equal g of f of x, and does both of those equal to x? So f of g of x is 3 minus 2, then negative 1/2 x minus 3, which is going to be 3 plus x minus 3. The negative 2 to negative 1/2 cancel each other out. So then it's going to be 3 plus x minus 3, which is just equal to x. And then we're going to go ahead and find f of g of x. So it would be negative 1/2, 3 minus 2x minus 3. It's negative 1/2, and then the 3's will cancel each other out, and then we can see that this is equal to x. So f and g are inverses of each other. So we do the same thing for number 38, right? We're going to go ahead and find out if f of g of x is equal to g of f of x, and if they're both equal to x. So f of g of x is going to be 2 times 1/2 x minus 3 plus 6, which is going to be x minus 6 plus 6, which is equal to x, right? If I distribute to 2, and then g of f of x is going to be 1/2 2x plus 6 minus 3. So then 1/2 times 2 is just going to be x plus 3 minus 3, which is equal to x. So then f of x and g of x are inverses of each other. So, oops, sorry, that's kind of stuck here real quick. So let's go ahead and do number 44. For number 44, what they're asking us to do is to find out again if f of g of x is equal to g of f of x, and if they're both equal to x. Now, so let's do the first one. So let's do f of g of x, which is 3x plus 5 over 1 minus 2x minus 5 over 2 times 3x plus 5, 1 minus 2x plus 3, right? And so here, which I'm going to go ahead and combine these. So it's going to be 3x plus 5 1 minus 2x minus 5, 1 minus 2x, and then 1 minus 2x. I just kind of put that together. So then here I'm going to do 6x plus 10 over 1 minus 2x plus 3, 1 minus 2x, and then 1 minus 2x, right? So I can put the 3 together. And so I can combine these, so it's going to be 3x plus 5 minus 5 plus 10x. If I distribute the 5, it's going to be 5 times 1 is 5, 5 times negative 2 is going to be negative 2x, but then I have the negative outside. It's going to be 1 minus 2x, and then this will be 6x plus 10 plus 3 minus 6x all over 1 minus 2x. So the 5's here are going to cancel out, so I'm left with 13x over 1 minus 2x. And then the 6 is going to cancel out, so that's going to be 13, 1 minus 2x. 13x, 1 minus 2x times 1 minus 2x over 13, which is equal to x, right? So f of g of x there, I'm going to have to move these down a little bit. It's going to be 54. So next thing I'm going to do is I'm going to go ahead and find g of f of x. So that's going to be 3, x minus 5, oops, let me do a whole fraction before I forget. So x minus 5, 2x plus 3, plus 5, and then 1 minus 2 times x minus 5, 2x plus 3. So then this will be 3x minus 15 over 2x plus 3, 5, 2x plus 3, 2x plus 3, right? You guys got to make a fraction that's equal to 1. So this one's going to be kind of easy because this is just going to be 2x plus 3, 2x plus 3, that's my 1, minus 2x minus 5 over 2x plus 3. So then the top, this will be 10x plus 15. So it's going to be, for this one, it will be 3x minus 15 plus 10x plus 15, right, over 2x plus 3. Sorry. And then this will be 2x plus 3 minus 2x plus 10 all over 2x plus 3. Combine like terms, so here I have my 13x, 2x plus 3. And then this one here is going to be 13, 2x plus 3. And so then this will just be 13x over 13, which is just going to be x. So then f and g are both inverses of each other for both of those. I think the next one that I had was 54. 54. Hold on a second, let me make sure. I just finished 44, so 54, yeah. So in 54, what they're asking us to do is to find the inverse of the function. So I'm going to go ahead and do that. Let me erase this here, delete this here. So 54 is f of x is equal to 1 minus 3x. So the first thing is you're going to replace y, or f of x, with y. That's your first step. Second step is you're going to interchange x and y. So swap f of x with y. Interchange x and y. Solve for y. So it's going to be x minus 1 is equal to negative 3y. So it's going to be x minus 1 over negative 3 is equal to y. And then here we're going to replace y with f inverse of x. So f inverse of x is equal to x minus 1 over negative 3 for number 54. And so the assumption here, of course, is that they are one-to-one. So f of x is 1-to-1. And we're going to also write this one as 1 minus x over 3. So that's the inverse. And then we can verify them. We're not going to verify them here right now, but we can verify those by just finding out that f of inverse of x is equal to x, and then the f inverse of f of x is equal to x. But since we worked it out ourselves, and we can be sure that it is equal to that. So let's look at number 64. They're asking us to do the same thing. So number 64, f of x is equal to 4 over 2 minus x. So I'm going to write it as y is equal to 2 minus 2x. Then I'm going to switch around, interchange my variables, and I'm going to solve for y. So it's going to be x times 2y, 2 minus y. So 2x minus yx, or xy, sorry, let me do it that way. It's equal to 4. So it's going to be 4 minus 2x. And then if I divide by negative x, I got my negative x here, which will be 2x minus 4 is equal to x, which is equal to the inverse of x for number 64. So that's how you do number 64. Same thing as the previous one, 54. And so, of course, when you do this one, you're just, looking for just swapping, so finding the inverse. The first thing you do is you exchange f of x for y, and then you exchange the y and the x, then you solve for y, and then you exchange the y for the f inverse. So this is not the same as this, right? So that does not equal that. So that's just the inverse, not the 1 over f, if you will. You gotta be careful with that. All right, so the next one is 66, and let's look what 66 looks like. So in 66, they're asking us to do the same, right? So let's go ahead and do 66 here real quick. So 66, f of x is equal to negative 2x, x minus 1, so then y is equal to negative 2x, x minus 1. So then x is equal to negative 2y, y minus 1. So I'm going to multiply both sides by y minus 1. So it's going to be negative 2y. So it's going to be xy minus x is equal to negative 2y. And so what I'm going to do is since I'm solving for y, I'm going to go ahead and put the y's in the same side, on the same side. I'm going to just add x to both sides and then add 2y to both sides. Then I'm going to factor out a y from that, and I'm going to divide both sides by x plus 2, sorry. And so then this is just equals to the inverse of x. And of course you verify it, you'll get that is true. Then the last one is 72. So let's do 72 here real quick. So I'm just doing really the algebra so you guys can kind of see it. So negative 3x over minus 4, x minus 2. So y is equal to 3x minus 4, x minus 2. Exchange the variables and then solve, right? So it's going to be x, y minus 2. So you see the procedure, the steps are pretty much the same, right? xy minus 2x, negative 3y minus 4. Let's move the y's to the same side. And then here's going to be negative 4 plus 2x. Let's take out a y. And then let's divide both sides by x plus 3, which is going to be the f inverse of x for number 72. And so at this point in time, of course, if we wanted to double check them, we can. I'm going to rewrite this one a little differently. It's going to be 2x minus 4x plus 3. And of course, they are in fact inverse. So if f of x is negative 3x minus 4 over x minus 2, the inverse of that is 2x minus 4 over x plus 3. And that is the end of 6.2. Thank you.